Now let's look at some specific types of transformations called translation, reflection, dilation, and rotation. A translation is a transformation in which a geometric figure is moved to another location without any change in size or orientation. Every translated figure, called the image of the original figure, is congruent to the original figure. So you can see here that this T has slid in this direction. It hasn't spun or gotten larger or smaller. It's just sliding down and to the right. And this shape is just sliding to the right. It's not spinning, it's not being enlarged or reduced. It's just sliding to the right. In the translation that moves triangle ABC to triangle A prime, B prime, C prime, point A has moved to point A prime, point B has moved to B prime, and point C has moved to C prime. And in a translation, all points of the figure move the same amount in the same direction. So the length of A prime, that segment, is equal to the length of B prime, is equal to the length of C prime. And all of these paths are parallel. Since the figure is moving in the same direction, all points are moving in the same direction. So therefore, triangle ABC is congruent to triangle A prime, B prime, C prime. Sometimes we call this the pre-image, so the image before it's translated, and this triangle would be called the image. A translation has a horizontal component and a vertical component. If movement with respect to the x-axis is L units, horizontal component, and movement with respect to the y-axis is m units, vertical component, then for any point A with coordinates x, y, its coordinates become A prime, x plus L, y plus m. So if we translate triangle ABC 6 units left, that's like a movement of -6 units with respect to the x-axis, and 6 units down, that's a movement of -6 units with respect to the y-axis. Then every point, such as A with coordinates 3, 4, is going to become A prime with coordinates 3 minus 6 and 4 minus 6, -3, and -2. So that's one example. And look, A prime is at -3, -2. Every point does the same thing. 6 units to the left, and then 6 units down. A reflection is a transformation in which a geometric figure is reflected across a line, creating a mirror image. The line is called the line of reflection. So here's the line of reflection, and you can also think about it as if I were to pick up this letter in my hand and flip it over like a pancake over to the other side. It would look like this. So we have a mirror image in this figure too. Here's the line of reflection, and each side is a mirror image of the other side. This figure suggests a reflection of triangle ABC over the line K to give the image triangle A prime, B prime, C prime. A is a fixed point on the line of reflection, so A and A prime are the same point since that point is on the line of reflection. B prime is the reflection of point B in the line K. So B is transformed to B prime. C is the reflection, C prime is the reflection of C in line K. So C is transformed to C prime when it's reflected about the line K. These two examples on the top suggest reflection in a vertical line. So the left side and the right side are mirror images of each other. These two figures suggest reflection in a horizontal line. The top and the bottom are mirror images of each other. And these two figures down here suggest reflection in a diagonal line. So this figure is a mirror image of this figure when reflected across this line. For a reflection in the x-axis, the x-coordinates are the same and the y-coordinates are the opposite. So think about reflecting this triangle ABC in the x-axis. So you can think about it as picking up this triangle and flipping it over like a pancake onto the other side of the x-axis, so it's going to land right here. So since B is 1 unit away from the x-axis, B prime is also going to be 1 unit away from the x-axis at 1, -1. So the x-coordinate is the same, the y-coordinate is the opposite. And A, with coordinates 1, 3, is going to be reflected down here to A prime at 1, -3. And C at 3, 2 will be reflected to 3, -2. So by doing it that way, keeping the x-coordinates the same and using the opposite of the y-coordinates, we'll be able to plot the reflection of triangle ABC, which is triangle A prime, B prime, C prime, in the x-axis. For a reflection in the y-axis, the y-coordinates are the same and the x-coordinates are the opposite. So to reflect triangle ABC in the y-axis, A and A prime will have the same coordinates, 3 and 3, B and B prime, 1 and 1, and C and C prime, 2 and 2. It's the x-coordinates that change this time, because this figure is moving to the left. So 1 becomes -1, 1 becomes -1, and 5 becomes -5. A dilation is a transformation in which a figure is enlarged or reduced with respect to a point called the center of dilation. For the dilation of a geometric figure, this is a transformation in which all dimensions are lengthened or shortened by a common scale factor. The smaller figure above, which is this figure, is dilated with a scale factor of 2 and a center of dilation C to produce the larger figure, which is this one. Now, I know that the center of dilation is C because the larger figure seems to have grown out from this point. So everything is growing in this direction. And I know that the scale factor is 2 because whereas the length of this side is 2, the length of this side is 4. So to go from 2 to 4, that's multiplying by 2. Translate the triangle 4 units left and 5 units down. So let's start with A, 2, 4. And to get A prime, 4 units left, we'll just subtract 4 from the x-coordinate, and 5 units down, we'll just subtract 5 from the y-coordinate. So the coordinates for A prime are going to be 2 minus 4, which is -2, and 4 minus 5, which is -1. Or you can just start at A and count. 4 units left brings me to -2 with respect to the x-axis. 5 units down, 1, 2, 3, 4, 5, brings me to -1 on the y with respect to the y-axis. So here's A prime, and for B, which had coordinates 3, 1, to find B prime, we'll subtract 4 from the x-coordinate and subtract 5 from the y-coordinate. So the coordinates of B prime are -1, -4. Or, of course, we can just count again. 4 units left, 1, 2, 3, 4, gives me the -1. And 5 units down, 1, 2, 3, 4, 5, brings me to -4. That's the -4, which we already calculated. And for C, 4 units left, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5, should bring me to 1, 0. Let's check that with the other method. So C prime is going to be 5 minus 4 and 5 minus 5, or 1, 0, which we got just by counting. So here's C prime, and connecting the dots gives me the image of this triangle after the translation, 4 units left and 5 units down.